Okay, so we're looking today at notes for 10-3 arcs and chords. Up until now, you should have corrected homework 1 and look at the information on the sideboard. Homework 2 will also be corrected in 7th hour on Friday. Since you didn't have class on Thursday. Homework 3 will be due for everyone on Tuesday. So 10-3 is on arcs and chords. There was a handout for you to copy this information before you got started on the recording. Arcs are pieces of circle. Chords are segments that touch the circle in 2 places. In the previous 2 sections, we learned about arcs and chords and some relationships. Now we're going to see how they're related to each other. So our essential question is, can you recognize and use relationships between arcs, chords, and diameters? The reason the word diameter is in there is it is a chord, as we well know. The first thing that I'm going to do is just go over some things. You don't have to write this. This is just a little reminder. And that is about a bisector, and just reminding you that if something bisects something else, it cuts it into 2 equal parts. So if you have a segment bisector, it cuts a segment into 2 equal parts. If you have an angle bisector, it cuts an angle into 2 equal parts. When it's a segment, we get that midpoint of the segment. And just to kind of let you know that that's kind of some of the things that we're looking at. The next thing I'm going to do is I'm going to pause this for a moment while I hand out the handouts. Maybe in 7th hour you'll have already gotten the handouts. If not, you can also pause this and give out the handout. Time allows here. Okay, so we're going to go through the theorems on this paper, and then when we write our notes, we'll also write miniature versions of these theorems so that we're well versed in what they actually mean. So Theorem 10.2 says in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So I'm always going to underline incongruent circles because we know that if it's the same circle, they are congruent. So 2 minor arcs congruent if and only if corresponding, and I'm just underlining the C-O-R-R, corresponding chords are congruent. So what this means is that if the segment from F to G is the same as the segment from J to H, then the piece of the circle from F to G is the same as the piece of the circle from J to H. And I'll be highlighting on these just so that we can see what I'm talking about as we go. So if these are equal, you might want to mark them with 1 marking. Then these arcs are also congruent, and you might want to mark those with 2 markings so that we know. And this is a biconditional if and only if, so we can know this first part and we get the second part, or we can know the second part and we get the first part. There's a proof here, good thing to go over as just a little review. When you're in the time that you have to take the Minnesota Comprehensive Assessment, now the way that it works is it's a little interactive, and there will be proofs on the Minnesota Comprehensive Assessment, and they'll be kind of like this but a little easier because they'll have fill in the blanks, but they'll have a blank choices, and you actually physically slide them up into the spot. So the first thing is, please put that away. The first thing is we're given circle P, and that just tells us that P is the center, and we know that arc QR is congruent to arc ST, and we want to prove segment QR is congruent to segment ST. When you're thinking about our next test, I'm just going to circle those. This is the chords, or excuse me, this is the arcs. And these are the chords. I'm going to erase this, but just a reminder that notation and how we write them is going to be important. So when you take your next test, if it's a segment, it's a chord. If it's that little piece of circle, then it's an arc. So the first statement in our proof is identical to the given. So you can just write that that's the given. In one of the earlier sections in this little part, we were told that if I have two arcs that are congruent, then their central angles are also congruent. And that's what this says. And so I'm gonna highlight it in yellow, and then I'll get rid of the yellow writing. So if this arc and this arc, QR and ST are the same, then these central angles, QPR and SPT, those have to be the same as well. And that's in one of the previous sections that we did, 10.1 or 10.2, as you're kind of looking through notes or whatever. And it says, if arcs are congruent, their corresponding central angles are congruent. I will ask that you take a minute and just mark those two angles as congruent on the picture. I'm not sure why they marked the segments congruent that they're trying to prove, but it's on there and I can't take it off. The next statement is that segment QP is congruent to segment PR, which is congruent to segment SP, which is congruent to segment PT, and that is because all radii of a circle are congruent. So since they've already used one marking, we're going to use two markings. So mark each of those radii the same with two markings. And I'm writing in green on the slide, and so it's the green markings that you're looking at. Step 4 is triangle PQR is congruent to triangle PST. If you remember, we have methods of doing that. Look at the picture, and when you've picked what grouping of sides and angles you think those two triangles are congruent by, please raise your hand. So these two triangles are congruent. You're deciding which way that they are congruent. And it is side angle, side congruence. And if you remember, this is the side, the angle, and the side marked here, the side, the angle, and the side. So side angle, side congruence is what we're looking at for that one. Then once the triangles are congruent, in step 5, it tells us that segment QR is congruent to segment ST, and those are parts of these congruent triangles. We use a bunch of letters for that. Raise your hand if you know what that bunch of letters is. The bunch of letters is CPCTC. Raise your hand if you could tell us what those letters mean. Yes, and in 4th hour, we're finding that is corresponding parts of congruent triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. Just to kind of remember some things. Now, in these next couple theorems, I'm going to tell you some extra information that will help you get problems right as you go through this. These two, 10.3 and 10.4, are very related. So I'll read 10.3 first. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So we're going to write if diameter, and we'll just know or radius, is perpendicular to a chord, then bisects the chord and its arc. So in this situation, we know that diameter is AB, segment AB, is perpendicular to chord segment XY. We know that those are the same, and so that means that Z is the midpoint of XY, and the arc from X to Y is also cut into equal parts. So we're just going to mark these two pieces the same and those two arcs the same, so that we know what's happening there. Now, the thing I want to tell you about this picture, and really it applies to maybe even the next couple of pictures as we look at these, any of these next three things, theorem 10.3, 10.4, and 10.5, any of these next three, sometimes we'll be wanting to figure something out and it seems like we don't have enough information. When that happens, it often can help to draw in a line segment that will make a right triangle. As a matter of fact, look at this picture in 10.3 and notice if I drew in CX, CX is a radius. So if I knew something about the diameter, I might know something about that radius. And if I draw in CX, it gives me a right triangle that is triangle CXZ. And so on one of them, we'll just pick this first one. I'm going to ask you to draw in radius CX. The book authors will not always draw that in. They'll expect you to know that you can do that. And then I'm just going to remind myself that I get a right triangle CXZ. And then I can use the Pythagorean theorem, and we'll actually do that today as part of our lesson as we go to the other handout. Then this next one says that the perpendicular bisector of a chord is a diameter of the circle. So that's nice because sometimes in life we'll see a circular shape and we have to figure out something about that circle, but we don't know what the diameter is or we don't know where the center is or things like that. And so what this means is you could take any circle, don't draw this, just look at it. You could take any circle, put a chord on there and find the midpoint of that chord and draw a segment that's perpendicular, and that will automatically be a diameter. So knowing that diameter, half of it would be the radius, and then you could find the center. Or without having a ruler, you could find the center by drawing another chord and finding the midpoint of that and then drawing that perpendicular segment, and where those two lines intersect has to be the center. So this is a very powerful theorem that we're looking at for 10.4. And so the perpendicular bisector of a chord is the diameter. And again, we're not going to draw it in this time, but if I drew in CX, that would be a radius of the circle, and I could use the Pythagorean theorem possibly again there as well. The next one we'll use quite a bit today. It's 10.5. And here's what it says. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So I'm going to just underline incongruent circles. And then it's two chords congruent if and only if equidistant from center. And again, I can't emphasize enough that in these last three theorems, sometimes in practice, it'll seem like you don't have enough information to answer the question, but if you kind of look back at these theorems, it'll help you see that you actually are going to know enough about them. So on this one, if these two chords are congruent, so that would mean that the chord from F to G and the chord from J to H are the same, then they have to be the same distance. I'll just write in little fives. LX might be 5 and LY would be 5, and I'll mark them as congruent as well. Now, a couple of extra things on this picture, even though it's not written in this theorem, and I'll just write these in yellow and then I'll get rid of them. So since LY and JH are perpendicular, Y is the midpoint of JH. So if I needed to find a little piece there, I certainly could do that. And because this is perpendicular, if I extended it out, it would be a radius, and then it would cut that JH in half as well. So sometimes we can get even more relationships as we look at those three theorems, and we'll be using those a lot in our notes. Now, find this handout. I'm going to tell you that in the other hours, when I made these handouts, it's a little tricky to fit everything on them. So you might want to do some of the work of the problems on your actual notebook paper that you're going to attach this to, and that will help. The other thing is I didn't write what the known information is, so you'll have to be writing that on the slide as well. So for number 1, I'll read it to you. It says jewelry. A circular piece of jade is hung from a chain by 2 wires around a stone. And our given information is that segment JM is congruent to segment KL, and the measure of arc KL is 90, and then we have to find the measure of arc JM. So I'm going to write given segment JM is congruent to segment KL, and the measure of arc KL is equal to 90. And then I'm just going to write find the measure of arc JM. This problem should be a pretty straightforward problem. So the first thing I'm going to do is mark right on my picture that segment JM is congruent to segment KL. It's already marked actually on our picture. And then I'm going to notice that arc KL and arc JM are those matching arcs. I'm going to write myself a note then that if KL is 90, then the measure of arc JM has to be 90 the same. And I'm going to write the reason for that in a very short way. These chords are the same, so those arcs are the same. And we're just going to write this way. Congruent chords have congruent arcs. And I'll ask that you write that as well. It'll help your brain kind of remember that that's what we're looking at. Congruent chords have congruent arcs. So some of our problems are just recognition, pretty straightforward, just what is the relationship between those two things. Now, our next problem is one where I think we might have to kind of write a little bit someplace else. This is number 2. I do want you to write the given information on the slide. Notice it says circle A is congruent to circle B. The nice thing about it saying that is it is identifying or establishing the fact that A and B are the centers of those circles and that they are the same size. And we also know that arc WX is congruent to arc YZ. And that's marked on our picture as well. Our job is to find WX. And so we want the distance from W to X. On your picture, the arcs are marked as congruent, so we know that congruent arcs have congruent chords. And that's backwards from how we wrote it before, but I am going to write that. Congruent arcs have congruent chords. And if you're writing that down, it's just formalizing in your brain these relationships as you're looking at them. So then I'm going to mark those two segments as congruent using two markings. And then that means that Wx is equal to yz, and I can write an algebra equation and solve for x. Here's my algebra equation. 7x minus 2 equals 5x plus 6. I'll give you a moment to figure out what x is. And in fourth hour, I'll be coming around the room and checking your answer. In seventh hour, I'll be writing up the work and showing you the answer in a few moments. Okay, so when you solve this, and I'm going to go kind of fast, but I will solve it, I would subtract 5x from both sides. That's 2x minus 2 equals 6. I would add 2 to both sides. That's 2x equals 8. Dividing by 2, x is equal to 4. In this situation, we were asked for Wx. When I walked around in fourth hour, I noticed some people had already calculated Wx. To find Wx, we're going to take 7 times 4 minus 2. That's 28 minus 2. So Wx is equal to 26. And if you accidentally found YZ, you would get the same answer, but just making sure that if the problem asks for one of the actual lengths, that you figure that out as you go. So that's problem number 2. For number 3, we're going to write that given information again, and on this one you have room on the right side of the picture. I have room on the left. So for number 3, circle G, measure of arc DEF is 150, and we have to find the measure of arc DE. Just a little side note from earlier work in this chapter. If you visually look at arc DEF, notice it's less than a semicircle, so it is a minor arc. But remember, a minor arc can be written with 3 points or 2 points. In this case, they're using 3, probably because they're also using just arc DE as we look at that. Now, for this one, we aren't told a lot of information, but notice on the picture that segment EG, which is a radius, and segment DF, which is a chord, are perpendicular. So if a radius is perpendicular to a chord, then it cuts the chord and the arc into congruent halves. So we're going to write this down. We're going to say radius, segment EG is perpendicular to chord segment DF. So the arc and chord are bisected. And again, bisected means that they're cut in half. So we actually know a bunch of things that were not even asked for in this problem. So if DH is 5, then HF is also 5, and that chord DF is 10. Since we were told the measure of arc DEF, that whole arc right there is 150. These you can mark as the same. So then that means the measure of arc DE is 150 divided by 2, or 75. And you might even want to mark DH and HF as congruent, just so that as you do other problems, you know those are also the same. Now, problem number 4 is probably a little bit more challenging. It's one that if you don't remember that you can draw in extra things, you might think when you look at it, I don't have enough information to solve this, but you really do. It's also a problem that I just sketch so that I can see it a little better because it's a little dark on my slide. I'm not using a straight edge or a ruler or anything. If you want to sketch it again, I would suggest that you sketch it on your actual notes so that you can write the work that goes along with it. And so what I'm going to do is just draw kind of a circle and sort of a square looking shape inside of it, and then right through the center there, I'm going to mark C as the center. Way over on the left is point A. D is this point where those two intersect. That is a right angle. B is out at the edge on the circle. E is the point up at the top left corner, and F is down at the bottom right. For this one, I'm also going to just write what the given information is. It says in the ceramic stepping stone below, diameter AB is 18 inches long. So diameter, we're going to write this down so that we know the given for number 4. Diameter, segment AB, where AB equals 18 inches. And chord segment EF, I'm not going to write that it's a chord. Visually, I can kind of see that. Diameter is just a little more important. Segment EF has a length, so I'm just going to write EF equals 8 inches. And my job is to find segment CD. Oops. Nope, the length of segment CD. So I want to find the distance from C to D, and I'll just put that there. Now, I want you to notice that in the picture, the diameter AB is perpendicular to the chord EF. So diameter AB, segment AB, is perpendicular to the chord that is EF. And since that's perpendicular, it cuts both of those in half. So I'm going to mark ED and DF as congruent. So all right, so ED is equal to DF. Those lengths are the same. And it doesn't matter whether I figure out ED or DF, but I know, and I'll highlight with yellow because I'll get rid of this in a minute. I know EF was 8 inches, so then that means this little piece and that little piece will be half of 8 or 4. So then I'm going to write over here that ED is 8 divided by 2, which is 4. I'll try to write that in. My picture's just a little small, but I'll write that in a little bit as I go. Now, the thing to get this kind right is you want to write yourself a hint. The hint is draw a radius to make a right triangle. Draw, and actually I'm going to write what radius I'm drawing in. Draw radius CE. Draw radius CE to make a right triangle. And then we can use the Pythagorean theorem. And since CE is a radius, I know the diameter was 18, so the radius is 18 divided by 2, which is 9. And so I'll label that as 9. CD is what I'm trying to figure out. I'll call it X. And then I'm going to use the Pythagorean theorem to find that. The Pythagorean theorem, which says a squared plus b squared equals c squared. X is like a or b, so x is the square root of 9 squared minus 4 squared, square root of 81 minus 16, square root of 65. The next thing I need to know is what the square root of 65 is on a calculator. Take a moment, do that, round it to 2 decimal places. 8.06 inches is what x is. So the problem isn't hard if you do this right triangle thing, but if you don't draw on the right triangle, it could look like you don't have enough information to do the problem. So just be careful there. Our last problem of our notes is number 5. And we're going to write the given information again. So this is circle P and comma EF is equal to GH, which is equal to 24. And we have to find the length from P to Q. Some of these visually just they are what they look like, but the theorem that we're using is theorem 10.5. So if you'll just take your handout and just read to yourself theorem 10.5 a second. Now, you know from reading that if chords are equidistant from the center, then they're going to be congruent. We know that EF and GH are the same length, and so in this case, since those are the same length, they're going to be equidistant from the center. So mark PQ and PR as congruent. And then you can write an equation, 4x minus 3 equals 2x plus 3. And then take a moment and solve for x and then find PQ. And I'll give you a moment to do that. In 4th hour, I'll be walking around to see your answers. In 7th hour, I'll write up the answers in just a moment or two. So we're going to, and this one I'll just work out, subtract 2x from both sides, and 2x minus 3 equals 3. Then adding 3 to both sides, 2x is equal to 6. Dividing by 2, x equals 3. If we stop there, we don't have our final answer. Reminder that PQ is 4x, which is 3. 4 times 3 minus 3, 12 minus 3. And so PQ is equal to 9. And so that's what we're to do on that problem. Now, the next thing you're going to do is write your questions and summaries, and then work on your in-class assignment, and then you're going to work on homeworks 2 and 3 that are due, homework 3 that is due next Tuesday.